Hello students, in this video I will tell you about velocity. It's previously I have explained you that velocity and speed, there are two terms those express the rate of motion, that motion is fast or slow. So next term I will discuss in this video, that is the velocity. So see this velocity. Velocity. In the case of velocity, I will tell you here that distance covered by a moving body in per unit time in a straight line or in a particular direction. Once again, distance covered by a moving body in per unit time into straight line, into straight plane, or in a particular direction. So this physical phenomenon is known as velocity. Once again, so see this. In the case of velocity, the distance covered by a moving body in per unit time in a straight line or in a particular direction. In a particular direction or in a straight line called velocity. Now, here, as you know that velocity is measured into a straight line. A straight line is related with displacement. A straight line is related with displacement. So, on this basis, we can say that velocity is dependent upon displacement. So, see this. Velocity is equal to distance covered by a moving body in a straight line, distance in a straight line or in a direction. Distance in a straight line or in a direction upon time taken. So velocity equal to distance in straight line. So distance in straight line is the displacement. Displacement upon time taken. Now velocity denoted by v, displacement denoted by x, but in your book it is denoted by s, and just like the distance, so you will not be confused. So displacement, yes, and time taken, as you know, that is the t. So velocity v equal to s by t. Equation 1. That means velocity is dependent upon displacement. Velocity is dependent upon displacement. So displacement upon time taken. And after that, unit of velocity. Unit of velocity. Unit of velocity from equation 1. So unit of velocity equal to unit of displacement upon unit of time. Unit of velocity is equal to unit of displacement meter. Displacement is also related with distance. Displacement is also related with distance. So this unit of displacement will be seen at the unit of distance, means meter, upon unit of time, second. Using notation meter upon second, otherwise meter per second, otherwise meter into second inverse. That is the unit of velocity. Means unit of velocity is the same just like unit of speed, meter per second. On this pattern, some properties of velocity. Note. Properties of velocity. Properties of velocity. Number one. Velocity. In the case of velocity, I will tell you here that velocity needs direction as well as magnitude. Velocity needs both direction as well as magnitude. So the velocity is a vector quantity. Velocity needs both magnitude as well as direction. So it is a vector quantity. Vector quantity. Number two. Velocity is dependent upon displacement. Previously I have told you that value of displacement can be 0. So the value of velocity can also be 0. Value of velocity can be 0. That's, and after that, because because velocity is dependent upon displacement, value of displacement can be 0, so velocity can also be 0. Next point. Types of velocity. Types of velocity. Types of velocity. Velocity also be described by two ways. Number one, uniform velocity. Uniform velocity. Number two, non-uniform velocity. So previously one by one, uniform velocity, uniform velocity. Same thing. In the case of uniform velocity, I will tell you here that as long as a body is moving into straight line, as long as a body is moving in a particular direction, till that velocity will be uniform. But as the brake applies on moving body, velocity change, non-uniform. As the moving body takes turning, velocity change, non-uniform. So in this situation, you can say that as the conditions of velocity, the conditions in which velocity is happening, the condition at which velocity takes place, if those conditions are changed, velocity change and becomes non-uniform. So we are now discussing about uniform velocity. So same thing, that when a body goes equal distance into equal interval of time in a particular direction or in a straight line, is called uniform velocity. So this is when a body covers equal distance into equal interval of time. Interval of time in a straight line, or in a particular direction. Direction called uniform velocity. Note that previously I told you about the speed, that uniform speed is not possible, so the uniform velocity is also not possible. Uniform velocity, because when we start our motion, so it is not possible that with the same velocity we can travel from our reference point to station point. Sometimes direction change, sometimes speed change, sometimes you can say path change. So in this condition, these are the conditions: at the path change, velocity change; at the direction change, velocity change; at the brakes are applied, velocity change. And these are happenings continually when we are in motion. So on this basis, we can say that uniform velocity is not possible in our day-to-day life, but it may be possible only for a short distance, for a short length. So our travel cannot be happen into a short length, so our velocity cannot be also uniform. So velocity cannot be uniform. Velocity cannot be uniform in our day. Velocity cannot be uniform in our day-to-day life. That's. But even some examples may be just like velocity of a plane, velocity of train for a particular distance, for a short distance, for a limited distance. That's. Next one. In this way, I will explain you with the example. Suppose it is a circular track and a body is moving here. Suppose here is a body that is on the path. So I told you that velocity should be in the case when a moving body covers a straight line distance, otherwise in a particular direction. It is a circular track. So on a circular track, straight line motion is not possible, because for straight line motion it should go by this way, but its track is here. So in this situation, in velocity, in the direction of velocity and in direction of real path, there is a gap of some particular angle, suppose that is theta. And when a moving body circulates on a track, so on every point this interval of theta takes place. On every point this interval of theta takes place. So by this way you can say that on a circular track, on a circular track velocity is not possible. It always changes its direction, and for velocity we need only straight line motion for a particular direction. So uniform velocity is not possible here also. After that, I will tell you about non-uniform velocity. Non-uniform velocity. Non-uniform velocity. In the case of non-uniform velocity, I will tell you here that non-uniform velocity is the real velocity that happens in our day-to-day life. This velocity is always, because when we travel regularly, when we travel daily, when we travel one place to place, so it is not possible, it is not necessary, it is not important we should go in a straight line. We change our path, we change our direction to reach from a station. So for this, in our daily to daily life, in our day to day life, the real velocity that declares, the real velocity that clears, the real velocity that expresses is non-uniform velocity. So non-uniform velocity is the real velocity that we express in our general sense. So be ready, non-uniform velocity. The velocity in which a moving body does not covers equal distance in equal interval of time. Equal interval of time in a straight line or in a particular direction. In a straight line or in a particular direction. Called non-uniform velocity. In the case of note, the velocity that is performed by us in our daily day-to-day life is not example of non-uniform velocity. The velocity that is expressed or that is sponsored, otherwise that is performed. The velocity that is performed in our day-to-day life is non-uniform velocity. Non-uniform velocity is also known as real velocity. In this way, just I explained to you previously that for velocity also we need two quantities: distance, because in ordinary sense, distance is also displacement. So distance and displacement. So we can say if a moving body covers equal distance in different interval of time in a particular direction, otherwise a body covers unequal distance into equal interval of time in a particular direction. So these both are the example of non-uniform velocity. That's all. And in next video, I will tell you about some sequences related with velocity and speed, their differences and numerical problems, etc. Thank you.